Okay, today we're going to look at the discrete random variable versus the continuous random variable. Alright, so the first thing we need to do is determine what a random variable is. Okay, and what a random variable is simply variables that have had their values determined by a probability experiment. Okay, so variables that have had their probabilities determined by a probability experiment. Now I probably should put values right here actually. Now when they say variable here, they're not talking about X, Y, and Z. They're talking about an actual noun, like flipping a coin. You either get heads or tails. Okay, so it's not X, Y, Z, it's an actual noun. Okay, alright, now from that random variable we have two types of variables. Okay, alright, but let's look a little bit closer at this. Alright, so going back to flipping that coin. Alright, when you flip a coin, if we let t equal the number of tails possible from our probability experiment, okay, then our sample space, now remember sample space is whatever outcome you can get. So what are your outcomes from flipping a coin? Well, you either will get a head or you're going to get a tail. So that's your sample space, either heads or tails. Like if you were rolling a six-sided die, what is your sample space? 1, 2, 3, 4, 5, 6. Okay. All right. So after one flip, let's say we get a we let t equal 0 or t equals 1. We either get a tail or we don't. All right. So from there, we're going to go to a discrete random variable. Alright, so this is a more specific type of random variable. Okay, so a discrete random variable is simply a variable that has a finite number of values. Okay, sometimes I refer to this like they're whole numbers, like things that are discrete are like the number of people. You can't have 1.4 people, or the number of days you go to school. You can't go to school 36.2 days. Okay. Alright, so like flipping a coin. Let's say you flip a coin 6 times. Alright, so you could flip it 1, 2, 3, 4, 5, 6, or 0 times. On the other hand, we have a continuous. There we go. Random variable. And I think that pretty much explains what it is. Continuous kind of means it keeps going on forever. It's kind of like it has infinite number of outcomes. Alright, so I think the example they gave on the slides were measuring the heights of people. So somebody could be like 5 foot, somebody could be like 5 foot, 5 foot 2 inches, somebody could be like 5 foot 2.7 inches. So it's very, you got a whole unit, you got a partial unit, you got a whole unit and a partial unit, etc., etc. So it can be in between. Okay, so they'll have a things we measure that can have an infinite number of values. There's no set to it. Okay, all right. So let's try this out. Discrete or continuous. All right, and sometimes depending on how you look at this, you may see it one way and somebody may see it a different way, but sometimes it's just very obvious. Like time left on a parking meter. Alright, so you could have like 1 minute, 12 seconds, 3 minutes, 42 seconds, etc. So it, even though it's not a specific amount, it's still like different amounts. But so some people might consider this discrete because it's going to eventually run out. This one's one of those tricky ones. Time left on a parking meter. Alright, so I'm going to say this is continuous. Alright, number of bats broken. Well, you have to have a whole bat to break it, so that's definitely going to be discrete. Number of fish in a pond. Okay, so that's definitely discrete because you can't have anything in between. You can't have 2.7 fish in a pond. Alright, total pounds of fish caught. Alright, so you could have like 7.23 pounds, 2.84 pounds, etc. So that's definitely going to be continuous. Alright, number of gumballs left in a gumball machine. Alright, that's definitely going to be discrete because you're going to have 312 gumballs, 210 gumballs. You're not going to have a half a gumball or a part of a gumball. Time spent by a doctor with patients. Alright, so he could spend 15 minutes with somebody, but the next person can only spend maybe 3 minutes and 42 seconds. It's going to vary, and it's not going to be a set number. So here, I'm going to say this is continuous. Alright, a probability distribution. Alright, this is simply a way to display your probability experiments. So going back to flipping a coin. And again, I'm just following your slides that would be posted. Alright, so we got tails. And then the probability of getting a tail. Alright, so what's the probability of not getting a tail? Well, that is 50% because it's either heads or tails, right? What's the probability of getting a tail? Again, that is 50%. Now, whenever you have a probability distribution, your probability should always add up to be 100%. So that would be a 1.0, which we know if we move the decimal 2 places, that would be 100%. So again, probability distribution, the probability should always add up to be 100%. That's going to be important in some of the examples that we're going to look at. Alright, so looking at example 1 on the slides, okay, is the number of pets. So here's your number of pets, and here's the probability. So let's see, we got 0, 1, 2, 3, and then 4 or higher. It's 0.12, 0.20, 0.40, 0.15, and then they've got a B. They want you to find that. Alright, so the first question says, what is the probability that a student will have 2 pets? Alright, so the probability of a student having 2 pets, well, that's easy. That is 40%. What is the probability of a student having 1 or 2 pets? So the probability of 1 or 2, so the probability of 1 and the probability of 2. So that's your addition rule. This is going to be 0.20 plus 0.40, so that gives you, basically, when you change it to a percent, 60%. 2 or fewer pets. Alright, so 2 or fewer, that's the probability of 2 or the probability of 1 or the probability of 0. So again, that's your addition rules. That's 0.4 plus 0.2 plus 0.12. When we add all these together, let's see, that's 60, 12, is 72% when we convert it to a percent. Alright, and then what's the probability of B? 4 or more pets. Well, remember, this is supposed to equal 100%. Okay, and again, as a decimal, that would be 1, but moving that would be 100%. So what I'm going to do is simply come right here, And B is going to be equal to 100% minus all the ones that we already know, because we know everything but one value. So it's going to be minus 12 plus 20 plus 40 plus 15. So 100 minus all that is going to give us 13%. So only 13% of students have 4 or more pets. All right, for example 2. All right, we're dealing with TVs. All right, so we got 0, 1, 2, 3, 4, and then 5 or more. So it's 0.04, 0.38, 0.27, X, Y, and then 0.13. All right, it asks you to find the probability that a house in the community will have at least 3. All right, so at least 3, so that means they could have 3, they could have 4, or they could have 5 or more. So that is at least 3. So we don't know these two right here, but what I do know is everyone that's less than 3. So again, remember, this is supposed to equal 100%. So what I'm going to do is I'm going to say 100 minus these right here, because this is less than 3, so we don't want to include that. So that's what, 4% plus 38% plus 27%. Okay, and let's see, 100 minus 4 plus 38 plus 27 is going to be 31%. So 31% of the people have 3 or more televisions. Now they try to throw you off with this right here, the X and the Y, but we don't need to know this specifically because we want to know all of this together. So if we want to know all this together, then we just got to get rid of what we don't want. We don't want this, so we're going to take that out of the 100%, and what we have left over are these 3 combined. And finally, for example 3, all right, let's see, we're talking about tattoos, so let's see. All right, so 0 tattoos is 35%, 1 tattoo is 13%, 2 tattoos is 20%, 3 tattoos is 15%, and 4 or more is X. Find the probability that a person would have 2 or more tattoos. So again, we're going with these 3 pieces right here. That's 2 or more. We want this right here, so we want to get rid of that right there. So we're going to take that out of the 100 because all these together should equal 100%. So 100 minus 35 plus 13, and that's going to give us 52%. So 52% of the people polled have 2 or more tattoos.